Good day, students. Today we're going to look at number 7. Number 7 is on page 91 of your booklet number 2 with the ma1026 course, and it's in practice 3. So it's page 91, number 7, practice 3. And it's asking us to take a quadratic which is in general form, or most people refer to this as general form, but standard form is another name, and switch it over to vertex form, and then graph the parabola, of course, showing the vertex axis of symmetry and a couple of other points. So, as you can see, in this particular question, we're going to start with standard form. Now, what are the differences between these two forms? So let's have a look. When it's in general form, ax squared plus bx plus c versus y equals a outside of x minus h all squared plus k. Right? Now, we can tell a lot more when it's in vertex form about its parabola. When it's in the other form, we can tell the y-intercept, and we can tell things pretty quickly. One thing we do know, that a is the same in both. Okay, that a is the same. So whatever it is in one form, it's the same in the other form. All right. So that's a good thing. We need a, and a is easy to get. So we'll put a little check mark. Of course, then we need to find h, don't we? How do we find h? How does h come into play, and how does k come into play? So you need to find three things. You need to find a, h, and k. And if you can find those, then you can easily write that form of a quadratic. So let's go through the example now. So I'm going to label these different steps. Okay, so here we go, starting with the question given. Okay, and the question given is y equals negative 2x squared plus 4x plus 5. That's the quadratic given. Now, so first thing we got to do is figure out step number 1, and I'll do these in steps to try to organize it for you. So we need to find a. Well, that's pretty easy, isn't it? Because a is the same in both, and a is the coefficient of the squared term when it's in this form. Okay, that's a right there. So a is always a quick step in this process. So a is negative 2. So we have a. Now the second step is to find h. Okay, now how do we find the x coordinate of the vertex? Remember what h is now. H is the x coordinate, I'll abbreviate C-O-O-R-D, coordinate of the vertex. So the x coordinate of the vertex. That's what h is. Now how do we find that? Well, your teacher, I'm sure, has taught you now that the x coordinate of the vertex, which is the same as the axis of symmetry, is minus b over 2a. Now some people use h equals minus b over 2a. Some people say x equals minus b over 2a. So I'll write both. I'll write it like that. X is the same as h. Now we're looking at and h is the x coordinate of the vertex, and it's always minus b over 2a. Always. So that's a given fact. So let's put a little box around that, because that's something you're going to have to know every time you do this problem. You're going to have to memorize this fact, that the x coordinate of the vertex, which we call h, is always minus b over 2a. Alright, so let's continue with this step. So therefore h is equal to minus b. Now what's b? B is the coordinate of the x term. There's b right there when it's in this form. So b is equal to positive 4. Now we already know what a is. A is the coefficient of the x squared term, that's negative 2. So it's minus from the formula. I always put it in brackets, just force of habit, good habit. And 2 times whatever a is. So on top we got negative 4 over 2 times 2 is negative 4. Divide those out, so h is equal to 1. So now I know the x coordinate of the vertex, right? So h is equal to 1. Let's put a box around that. And step 3 is to find the y value, k. So how do I find the y value of the vertex called k? Right? Now remember, the vertex is hk, right? We know every vertex is hk. So if I already know h, which I do, h is 1, then put 1 in for h, or x in the equation, x and h, right? It's the x coordinate, and solve for k. So that's all we need to do. So we're going to take 1, substitute it in the given equation. Now let me write the given equation one more time. Minus 2x squared plus 4x plus 5. Alright, now let's put 1 in for x, so we get negative 2 times 1 squared plus 4 times 1 plus 5. Now what does that give us? Okay, so 1 squared, alright, negative 1, that's negative 2 plus 9, that's 7, right? Looks like it's 7, isn't it? That's negative 2 plus 4 plus 5, which is plus 9, so I get 7. Okay? So now we know what k is. So k is equal to 7. Let's put a box around that. Okay, so now we know a, we know h, we know k. So we just write the equation. So now let me write it over here. So step 4 is actually write the equation in that form, and here we go. Y equals a, negative 2, open bracket, x minus h, which is positive 1, so it's minus 1, all squared, and then add k to it, and k in this case is 7. So there's the answer written in vertex form. So now we went from general form, or some people call it standard form, to vertex form. So that we've done that. Now we're expected to be able to graph this as well. Okay? Now the key thing to do when graphing is put your vertex in. Very first thing. Now we know the vertex is hk, so our vertex here is 1, 7. So we need to put that on our graph. 1, 7. I think you can all see it here now. And label that point. Put it. Now this opens which way? Which way does it open? You can see it's negative there in front. So this tells us it opens down, doesn't it? So I'll label this vertex on top then 1, since it opens down. There you go. Now, what are other key points? Okay, other key points. Well, y-intercept is always a good point to get. And we know what a y-intercept looks like, right? Y-intercept is a point that crosses the y-axis. It occurs when x is equal to 0. So y-intercepts are important points to be able to find. Now, if you know that from general form the y-intercept is very easy. It's very easy to get y-intercept from this form. It's a little bit more difficult to get it from vertex form. Because if I put x equals 0 into that form, watch what happens. Negative 2 times 0 squared, of course that's going to be 0, plus 4 times 0 plus 5. So what are you going to get? You're going to simply get the c value. So when it's in this form, the y coordinate is always the c value. A right there. The y-intercept, sorry, the y-intercept. So I know it intercepts at 5. Right? Now it's symmetric. So if 0, which is 1 unit away from the vertex, right? If it's 1 unit away from the vertex, which it is, then the other point, symmetric to that, is 1 unit away on this side. So the other point's going to be right there. Okay? And that'll give you your 2 extra points. So I make a point to find, or you can do it table of values. You can plug any points in you want. Right? If you want to get another point, simply do up a quick little table of values. I'll do it down here. Right? You can do up a table of values. Pick a point on either side of 1. Right? So we'll put our vertex in the middle. Some people do this. They put their vertex right here in the middle, 1, 7. And they'll pick points on either side. Going left would be 0 and negative 1. Going right would be 2 and 3. And they'll actually work out several points Now we know 0 is 5, therefore since it's symmetric 2 will also be 5. Now if you plug in 3, what do you get? 3 minus 1 is 2 squared, negative 4, negative 8 plus 7, that will be negative 1. Right, so both of these. Now you just plug those values in. You know how to do that. Plug the values into the equation and solve. So if you wanted to plot more points to be accurate, negative 1 is right there. And there is, what's that one? That one's 2, 5. And then negative, and then 3, negative 1, which is right here. So I've got the 5 points plotted. Now it's a curve. Don't join it with lines. Remember, it's a smooth curve. So try to make it a curve. Now I'm drawing freehand here, which is difficult on this. So bear with me as I try to draw this. Oh, I'm going all over the place here. Let me just try that again. Maybe if I come up from here, it'll be easier. Okay, it's not bad there now. And you can check these on your calculator, which we're going to do, by the way. We're going to check this on our calculator in a second. Oh, not real good. Let me one more try. A little bit more curve to it. And then come down through this point as well. I'll put an arrow on it. So there's your parabola. Now it says also show the axis of symmetry. Remember, the axis of symmetry is a line that divides it right in half. So I'm going to bring up the line feature. Let's make it a little bit skinnier, and I'll put the line, the axis of symmetry. Okay, that's too skinny. Let me change the size on that. There you go. So the axis of symmetry, I just drew in there. That's a line that goes right down through the x coordinate of the vertex, and you can label that as well. That's x equals whatever the x coordinate of the vertex is. So there's your axis of symmetry. So that's a complete answer. Now let's go ahead and check that. Let me bring up my graphing calculator. And let's check that. Oh, there it is. Let's check that on our graphing calculator. Let me move it over here. Now, what form do you want to put it in? Let's put it, what form do we want to put in? Let me just clear that. So hit your Y equal button. See how I did that again? Just a Y equal button right there. Now, since we're given in general form, why don't we put it in general form and then compare it to our form? It's negative 2 x squared plus 4x plus 5. See that? Now let's hit the graph button there. And look, it's the exact same, very similar shape. A little bit more smoother than mine, but there it is right there. Okay, so it looks like we have that correct. And if you want to use the trace button or right here, you can calculate a value if you want. For example, we want to put in x equals 1 to see if we got 7 as our vertex, and we did. See, 1 and 7, so we know we have the vertex correct as well. Alright, so that's a complete solution to number 7 on page 91.